So the Poisson distribution expresses the probability of a given number of events occurring in a fixed interval of time or space if these events occur with a known constant mean rate and independently of the time since the last event. The Poisson is a discrete probability distribution since it is formed by counting. It's often referred to as the law of improbable events because the probability of an event happening is very small. A Poisson distributed random variable is often useful in estimating the number of occurrences over a specified interval of time. It's a discrete random variable that may assume an infinite sequence of variables, so x can be 0, 1, 2, 3, and so forth. Examples of Poisson distributed random variables can be the number of knot holes in 14 linear feet of pine board, the number of vehicles arriving at a toll booth in 1 hour, or even, when Bell Labs used the Poisson distribution to model the arrival of phone calls. So since there's not a stated upper limit for the number of occurrences, the probability function is applicable for any value 0 through infinity. And in practical applications, x will eventually become large enough so that the probability of x is approximately 0, and the probability of any larger values of x becomes so small that it's considered negligible. So we're going to look at an example of Budget Airlines is a seasonal airline that operates flights from Myrtle Beach, South Carolina to various cities in the Northeast. Recently, Budget has been concerned about the number of lost bags, and Poston from the analytics department was asked to study this issue, and she randomly selected a sample of 500 flights and found that a total of 20 bags were lost on the sampled flights. So the first thing we're going to do is begin by confirming the situation fits the Poisson distribution characteristics, which is we have a set amount of time with frequency, right? Now we're going to calculate the mean using the sample information, so 20 out of 500. Then the Poisson probabilities can be calculated using our formula. And we end up with a probability that 0 bags were lost was 0.9608. So then the probability that 1 or more bags was lost is going to be 1 minus p of 0, probability of 0 occurring, to give me 0.0392. Just like with the binomial probability distribution and the normal distribution, there are also tables available for you to look up these values for the Poisson distribution, as well as functions available within Excel to calculate these for you. Let's look at another example using the probability function. So Mercy Hospital has patients that arrive at the emergency room at an average rate of 6 patients per hour on a weekend evening. So what's the probability of having 4 arrivals in 30 minutes on a weekend evening? So here, our average is going to be 4 per hour or 3 per half hour. And what we're looking at is going to be 4 arrivals. So since the question was asking about 30 minutes, we went ahead and scaled the mean to be 3 per half hour because that's what the question's asking for. So we did 3 arrivals, or sorry, 3 raised to the 4, and then we're going to do 2.71828 to the negative third divided by 4 factorial to get 0.1680. So if we were to graph this, we would see that the Poisson distribution kind of goes up initially and then has a long right tail. So it's definitely not a normal distribution because we have this skew. And so that's something that we definitely need to pay attention to, is that sequence is going to continue on. A property of the Poisson distribution is that the mean and the variance are going to be equal. So when we were looking at our number of arrivals in a 30-minute period being 3 patients per half hour, our mean and our variance in both are both going to be 3. Let's go on and look at Joe's Coffee Shop. So customers arrive at Joe's Coffee Shop at the average rate of 4 per hour during the week. What is the range of arrivals per hour bounded by the mean plus and minus 2 standard deviations? So remember, our mean is equal to our variance, which is 4 per hour, and so therefore our standard deviation is 2. And so we were told that we were bounded by plus and minus 2 standard deviations, so 2 sigma is 4. My mean was 4, so my upper limit of the mean is 4 plus 4 to get 8. The lower limit of the mean is 4 minus 4 to get 0. So that means the range of 2 standard deviations around the mean is going to be from 0 to 8. So if we were to look at using a probability table, we can use the example of the New York LA Trucking Company finds the mean number of breakdowns on the New York to Los Angeles route is 0.3. So if we were looking at the table, we can say that the probability that we wouldn't have any breakdowns on a particular run by finding the x value of 0 and the 0.3 value across the top for the mu. At that intersection, we get the value of 0.7408. And so the probability of one breakdown is 1 minus 0.7408 to give us the value of 0.2222.